All right, welcome back. And, well, you saw it on the title screen. The goal today is to finish out the rule of five mess that I started in the last stream. And, well, we need to finish out. And I thought about it because I was thinking that I'm going to have to do a lot of work in order to get this working. Um, and no, we're going to, we'll, we'll do something else. I mean, excuse me. I'll talk you through how we can alleviate some of the problems with the rule of five. Basically, I thought it was going to have to be the rule of five all the way down, and I didn't want to do that. That is, I was going to have to implement it in several different classes, and like I said, I didn't want to have to do that. And I think I've got a workaround for that. So we're going to look at that. But first, I always like to kind of give an overview of something, and let's see. There we go. Make sure I've got the correct window selected, and I do. One of the commands we have, remember you can type in make help, and because I have a small little script in there, and it gives you all of the commands that you can run. And one of them is clock, C-L-O-C, count lines of code. And we are on, if I say get status, we're on branch master, but as it so happens, I can tell you we're on episode 6. That is, I mean, this is episode 7, but our current code state is where we were at the end of episode 6. And if you type in make clock, it will analyze it and give you a few bits of information. And what I care about is the amount of code versus the amount of comment. And you can see I have almost as much. That ratio will change, of course, but this amount will probably surprise some of you, especially if you're students who have never seen a lot of documentation. It's just for even large projects, I would say maybe a quarter of 25% of or rather, maybe I should say it's a 1-to-4 ratio, 1 part comment to 4 parts code. Or you could think of it as 1 line of comment for each 4 lines of code. And it's not a hard and fast rule. It's not saying you have to have that. But generally speaking, the smaller your programs are, the closer that ratio becomes. It can be 1 to 1. For each line of comment or for each line of code, you've got 1 line of comment. And again, it's not a hard and fast rule. Rather, it's to me a sign that I'm at least doing some, well, I was going to say something right in terms of documentation. Lines is not the only measurement, obviously, but if I were to examine a project and it's a small project and they have almost no comments for their lines of code, that's a big problem, especially if it's 100-to-1 difference or something. Yeah, there's something going on there. For ours, we're going to have some large sections of code, specifically in the program dump and in the program execute, because we have a big switch statement. And each thing that we can switch to may only be 4 or 5 lines, but when you've got 30 or 40 different things, you get to some pretty large code blocks, a pretty large function, and you don't need necessarily comments for everything. But anyway, we'll talk about that as we go. There's a lot of rules or guidelines that people talk about in programming that don't necessarily matter, and the whole thing, your function has to be limited to a certain number of lines, or you can only have a return at the end, or there's a lot of things that it's like when you're getting into larger projects, is like as long as your code makes sense and it's readable, it's fine. Okay, so what did I want to say about this? Well, since we're on Git, we can say like git check out episode, well, let's do 2. I think that's the first one. And now make clock and I only had 40 lines of code. Check out episode 3. Same thing. Significant jump in code. Check out episode 4. And then the clock. Again, we're going up. But you can see we also, by then we almost had a one-to-one parity between our comments and our code. And I understand this is across, Lex and Yak as well. So, but we have comments in there. Go back and look. I may not have put them in while I was recording, but trust me, they're there with links to the documentation and stuff, because so that way you can reference it. And check out episode 5. Make clock. We're up to 437, and now check out master, which is episode 6, and make clock 537. So we wrote 100 lines of code last time, but also looks like, what is that, 66 lines of comments. So all right, so now where does this put us? We want to continue the rule of 5 stuff, but so not Vim, we're going to make watch dash test. Yes, so that it's continually compiling in the background and telling me if I've got any errors, any problems. All right, so I think I want to try to intentionally have the include for program first. You know what? Will it let me do multiple? I don't know. If I do that, it does. Ooh, I could have preloaded this. So I also know that I'm going to need the computed. So this is include computed expression, and then the source computed expression. And then I'm also going to need AST, but that's in the include AST first, and then source AST. There we go. And that gives us program, then computed expression, then AST. Yes. All right, so let's go into the AST.hpp first. So :B5. And what we're going to do... Oh, I was like, why does it say class program? That was just a forward declaration. All right, so AST node. The problem is we need to be able to potentially make a copy of this. And the constructor is private, or excuse me, protected. Because we don't, generally speaking, want we didn't want a bare AST node. But we do need to be able to say, well, whatever type of AST node you are, give me a copy of yourself. And the problem is polymorphism. What if it's a pointer to an AST node, but that AST node is really of the type AST node integer? So what we need to do is we need to have a virtual function that we ask, give me a copy of yourself. That's what we're going to write. So right here, let's see, copy of the AST node recursively if appropriate. Sure. And I'm not going to pass it. There's no arguments, but there is a return type, and it is a pointer to a new AST node that is a copy of the current AST node. And yes, I'm hitting 80, and I am going to put that on a new line. Yep. That should be fine. And now it's going to return AST node star. Oh, wait. That should have been a virtual AST node start. And we're going to call this, should I say, I don't like copy. I like make. How about this? Make. No. Make copy. Okay, and I'm going to... this should be a const as well. Yes. Okay. No problems yet. Buffer 6. AST node. And now it is an AST node pointer. A pointer to an AST node. And what was it? Make copy. Const, and we're going to say just return a new AST node. Does it have, I think that's what it's called. Is that right? Location. Control buffer 5. No, it's giving me an error. It's just I need to... Yes, it is called location. There we go. That should get rid of the problems. Oh yes, because we need to do the integer one. So let's just copy all of that. All right, and does this compiler use, is it the... Is it first or second? This will... that should... It's declared private. That should be protected. Wrong one, Corey. AST node, protected, and private. Let's do 3. See if that's any better. Okay, it's compiling. And so now if I call AST make, make copy, I should get a copy. Now, why do I care about that? Let's go colon B2. There we go. In the rule of 5 stuff, this is our copy constructor. And so I said AST node. No, we're not going to do that anymore. We're going to say AST arrow make copy. And it should still compile. We're good. All right. We need to do the same thing. Well, error. No, error is fine. We can just use the standard. It doesn't have pointers that we're needing to manage, so that's fine. We need to do the same thing though with computed expression. All right, so I'm going to stick with make copy. Control B. I know it's colon B3. Public. Sorry, I know I'm thinking what order should they be in? It probably doesn't really matter. But let's do this. Okay, and the return is going to be a pointer to the new yes. All right, and this is going to be a computed expression pointer make copy. That is a const. And now down here, const and override. Computed expression. Computed expression. Yeah. So now let's see, what's the error it's giving me? It says it's marked an override, but it's not override. So what did I do wrong? Computed expression pointer make copy const. Computed expression pointer make copy const override. Oh, because I didn't declare it as virtual. That's why. There we go. We're good. And by the way, that's a case where override saved me. That would have been a while before I caught that error. By me telling it, I want it to override a virtual function, it was looking for it and it said, well, it's not virtual, so I can't override it. If I did not have virtual here and I didn't have this marked as an override, this would have compiled. But it would not have ever invoked make copy unless I was explicitly had cast the object to a computed expression integer. And that kind of defeats the purpose of this. I mean, yes, this isn't perfect. When you've got this virtual stuff, you have vtables that, you know, they're not as fast as if they weren't virtual, but they solve the problem in a very elegant way. So, yeah. Okay. Let's get back to the rule of 5 now. And this is, if we've got a result, there we go. Result is, we're going to say program.result. And remember, that's an optional, so we have to use the arrow to perform a dereference on it. And then and it's a pointer. So I'm going to mute myself while I do this. Never mind, it's a phone call. I'll worry about it later. I normally put my phone on silent. There we go. Okay. What was I saying? This is a pointer that we are dereferencing, and now use the arrow and say make copy. Yes. Now we're safe. Okay. So this is the copy constructor. And now when we make a copy, we're not just saying we're going to point to the same place that the pointer was pointing to, but rather whatever the pointer was pointing to, give me a copy of that. That's good. Now, so what's next? We did the copy constructor. The move constructor. And again, it looks like a constructor. So, but it's not declared as const anymore because we're going to steal from it. And we're going to say program with a double ampersand, and that means it's an R value. So it's a temporary value. Program. Yes. And now we can use the swap this arrow code with program.code. And Say, Corey, are you checking to see if they exist or not before you do this? No. And I shouldn't get any errors. The reason is because what does swap do? It just switches the two. And the whole point for these move constructors is that I can steal, S-T-E-A-L, what is in the source, the object program. I can steal it. So, but I have to leave it in a valid but I was going to say undefined. Is that the right word? Yeah, undefined is the right word. A valid but undefined state. Now, if I just swap the contents, then it is valid but undefined. And then later, its destructor will get called and everything will be cleaned up like it's supposed to. And that's what is happening up here. Error should be up here as well. Yes. Okay. We will. We'll run. Is it valgrind? I think that will check for memory errors and stuff like that. Make sure I got everything. All right. So yeah, that was simple. So now I've got 3 out of the 5. All that I need now are my assignment operators. So the first one is a copy assignment. So copy assignment says I'm going to return a program by reference, and it's going to be called program operator equals, and what is it fed in? A const program under. There's a lot of programming here. Huh. Anyway, all right, so this is when I'm this is generally exactly the same as what's happening here. That is, this is saying A is equal to B. A already exists, and that's the this. And so this isn't, it's not the same. If I currently have a value, I need to dispose of it appropriately. Yes. Okay. So, first of all, this arrow code, that is a string. So I can, this is perfectly fine. This is an enumerated type, but again, it's a base type. So that's fine. This arrow AST. Do I want to call its make copy? Yes, but I need to say if this arrow AST, if I already have one, then I need to delete. No, this arrow AST. Is that right? I'm going to look at the buffer of 1 because I'm forgetting right now. Okay, so AST is a pointer, it's not an optional. Error is a pointer, it's not an optional. What about result? result is an optional. I probably should have made AST and error to be optionals as well. I'll think about that. So either way, oh, it's suggesting what what I should add, and that is I need to say return star this. That is correct. I just wasn't that far yet. So if AST, which is a pointer, is set, delete it, and then set it to be a copy of whatever program.ast is. Now the question is what if AST is empty? I'm going to do this. This arrow AST is equal to null PTR, null pointer. Now I will say if program.ast, if that exists, then make a copy of it. Okay, so what will that give us? If AST wasn't I'm just going to say there we go. And all right. So AST is a repointer, so clean up. If AST is empty, then it won't go into this line here. And then if program.ast is also empty, we'll come out and AST will still be empty. Yes. If AST is not empty, we're going to delete whatever it is and then assign it to null just in case program.ast doesn't have anything. And now, okay, yeah, that covers all of the bases. And then we'll say error is a pointer, so clean up before replacing. And it's basically the same thing. If this error okay, result is an optional, but and now this error result is equal to we've done this before and it's like optional null or something like that. I don't remember what it's named, what it's called. That's okay. That is what the internet was invented for, right? So C++ optional null. Null opt. Simple enough. That should work. Or is it optional colon null opt? Probably. Well. Yeah. Null opt. We should be good with that. And okay. And now if program result exists, then we're just going to make a copy. Okay, we're compiling fine. And last is the move assignment. And this is where it's an assignment, but we can steal things. So how do we do this? Well, again, we're going to return a reference to a program. And instead of it being const, it's a double ampersand program. Okay. And now, like I said, we're stealing it. So we can do swap of this code, comma, program.code. That's fine. Can we just steal all of it? Swap. It is, yes, we can. And then return asterisk this. And why is this okay? Because this will be disappearing. It's an R value. Somebody's going to probably point out an edge case to me. I hope not, but it may happen. But that is our rule of 5, and now we're safe, and we can look through it again. That is, we've got our constructor. That's not part of the rule of 5. But the moment we have a destructor, which means we had to delete error, AST, and result, which is an optional. And now we've got our copy constructor, our move constructor, our copy assignment, and our move assignment. We're in good shape. Everything is compiling. Okay, that's good. Let me check the time. We're 40 minutes in. Okay. I don't want to... let me tell you the problem that I'm mulling over in my head. And the problem is the stack. And the fact that we're returning a pointer to a pointer to a computed expression. Why is that bad? Well, there's a couple reasons. Number one, and here, I'll just go up here so you can see me really big as if you wanted to do that. The first problem is that the stack is going to grow and shrink a lot. And that means there's going to be a lot of calls to new and delete. And that is slow. Every one of them is a system call. And we would like to maybe reuse the memory, perhaps. And so I'm going over my head, well, what about an object pool of some sort? And so I've been looking for what are existing options for C++ object pools. And quite frankly, I'm not finding a lot of what I feel are promising options. There is one in the Boost library, but most of the stuff I've seen written about it is a decade old. And then a lot of people say, well, it's abandoned now. And yeah. So it's like, okay, well, should I write my own? I could. Then it would work how I wanted it to. And we could put into it the things that we need. But then what would we need? I can tell you this. We would want to, first of all, have a singleton class. That way anyone could just call the singleton class and say, and give me an object of this type. And we would want it to give us something from the pool. And then when it's ready to go away, we could say, well, okay, release it back to the pool. Recycle it. I like that word, recycle, for that function. Okay, well, if we do that, then we've got another problem. That is, do we want to be copying stuff that much? Let me put it this way. One of the things I really liked about my previous solution with shared pointers was that I could create a shared pointer, make a copy of it, and it's doing its own reference counting, of course. And anyway, and I could hand it off to something. And when it was done with it, the shared pointer would clean up after itself. We don't have that right now with our current solution. We're using bare pointers. And while bare pointers are fast, there's also the possibility of making a mistake or forgetting to free them or not knowing that you need to free them. And if we're using a memory pool, you can't just free it anyway. You have to recycle it back into the pool. Now, as it turns out, when I was playing around, I wrote, because I was testing, speed and everything. And I wrote my own class that would be a wrapper around the pointer, and it would do the reference counting. And when it was being deleted for the very last time, and that for that you have to take into account the rule of 5 and everything. But when that was done, then what was I trying to say? Sorry, my brain just stopped working. Okay, sorry, I had to hit pause and recollect my thoughts. And then I thought how funny it must look to you, and oh well. But yeah, so we've got to have a class that can take care of the counting, and then when the last version of that object is going away, its delete is called, then you would want to delete the pointer. But in this case, we don't want to delete it. We want to recycle it. And so why are shared pointers then not the answer? And one of the reasons is the speed. When you pass a shared pointer through a function, there is a big overhead. And some of our stuff that we do, we pass around these pointers quite a lot. And you can't turn off that overhead because it's worrying about thread safety. Well, that brings up another issue. What about thread safety? Well, as it turns out, our thread pool needs to be thread aware and it needs to be thread safe. But the way that I know that our program is going to be written, this container for managing, for doing resource counting on our, pointers that I'm planning on, it doesn't have to be thread aware. And that makes it where it can be faster. And I did some preliminary tests comparing shared pointers to bare pointers and to my wrapper class. And that the bare pointer and the wrapper class were neck and neck. I mean, they were extremely close in performance. And so then it's like, okay, well, can I turn this? Can I morph this solution into one that uses that where I have to write a wrapper class and write an object pool, and that would be the next step. And I want to do it before we do too much more work into this. That is, you don't want to we don't want to put too much work into it, because then you just have to refactor, and we don't have our unit tests up and going yet to catch memory or to catch regressions and things like that. So I want to get it done sooner rather than later. So that's it. We need two things. We need a memory pool, an object pool manager that evidently we're going to write ourselves. And a lot of the examples online are not exactly efficient in their examples. That's the first thing. And the second thing is we need our own reference counting wrapper class that we can use for these return values. Now, well, we could even do it with the AST nodes as well. And maybe we should. No, I like explicitly having our copy thing here, because we're not passing them around as vitally as we would with this other. But okay. So what am I getting at? I'm glad you asked. That's what we're going to do. We're going to have to solve those two problems, and then we can continue the work here. We've got to write those two utility classes. All right, now back here, because the last thing I'll show you is what do I do to get ready to release this, so to speak. And let's see. So get status. And the first thing I do is I say, well, what are all the changes that I made? So get diff. And I look through and I see, okay, I moved location. I removed this private stuff. And I added a comment. I'm looking for, there would be a red space if I had left some white space in there unintentionally. I don't like that. Like leaving the white space, so I don't have a coding style guide, so to speak, but I do have a writing style that I prefer to use, that I've used, and it's different in each language, right? Because my style of coding in Python is different from JavaScript and things like that. But oh well. Generally speaking, I would say I'm internally consistent, even if I can't explain it to you all the time. But oh well, I'm the only one working in this code base for the moment. I'm looking through, and oh look, at the end of AST node integer, there's 2 lines. So what would I do over here? And this is in the .cpp. So source AST, and I'm going to delete one of them. And here I can just rerun it and make sure that everything is okay. Oh, yeah, that was up here at the top. It was right there after AST node integer. So we're good on that. Continue looking. Make sure cleaned up my, or added my missing error pointer handler to the destructor. My changes to those. Yeah, everything looks correct. Now, get status. You saw me do this the first time, and I actually, that is, I just said get add and I tapped a directory name. I normally don't do that. Why? Because you could include something by accident. So add include AST, include computed expression, source AST, source computed expression, and then source program. There we go. Get status, make sure that I added what I intended to add. And now get commit -m, what is it? Finishing the rule of 5 for program. Okay, now we made some changes to the documentation, or I just want to verify that the documentation is correct. So now if I say get status, you'll see there's nothing there. If, however, let me do it over here just so I can say make docs-pdf, because why not just make all of it? There we go. Now, get status, we'll see that there's new untracked files, and they're all in docs. And then there's modified files. That's fine. And maybe I shouldn't commit all of these, but for right now I am. And if I want to verify them, remember I've got this command WSL view, and it is docs/HTML/index. And it should open a browser. There we go. And in my file list, I've got, yeah, all of the files. So what did I do? We just added stuff to, well, yes, AST and computed expression, but program. So where's program.cpp? Yeah. Whoops. There, just didn't click on the right thing. You see our macros are defined, and okay, and if we go to our classes, class list, program, copy constructor, copy assignment, move constructor, move assignment, you get the idea. And of course, all of our documentation. And last but not least, if I do WSL view docs/LaTeX /refman.pdf, we'll see this as a PDF, which you may get tired of seeing this, whoever actually watches this video in the future, but quite frankly, I think this is awesome. There's our pound define. I didn't know what it would look like, the macro definition. Yeah, a section, macro definition documentation. And our file reference and everything. Oh, it's beautiful. And I can't believe a 48-page document, including an index, was generated from just writing Javadoc, writing code documentation in Javadoc syntax, compiled by Doxygen into this. It's awesome. Anyway, all right. So now I would say git add, and in this case, yes, I will say git add docs and get status. Make sure just really quickly. Okay. Git commit, and the message is going to be update documentation for episode 6. Wait, is this 6 or 7? I'm going to switch to my title screen and find out. Okay. For episode... Whoops. Episode 7. All right. Get status should show us that there's nothing left. Last thing we need to do is, well, 2 things. You know what? Now I'm kind of curious. I'm just going to say git tag -a episode dot James Bond with a message, and right now I'm just putting the exact same API episode dot 007. And now if I say git push origin episode 7, will it do it, or do I have to push the... It did. Git push origin master. Does it do that as well? I had to update master as well as push the tag. Okay. But now in GitHub, I'll probably query p1. That's a user. There I am. My repositories. Let's go for Tang. And if you were to look at the tags, there's the episode 7. But the master is also episode 7. So yeah. That's what I do. And then, of course, I'm about to turn off the recording and start uploading to YouTube. So, all right. Well, if you've stuck around for this long, let's see. We're right at an hour, so that's probably long enough for you. And also, I mean, I've been streaming this on Twitch at the same time. Not that I've ever had somebody watching me. I've never had a single person log on. But the reason I'm doing it is I turn it on actually before I start recording, and usually even after I'm done recording. And the reason is it helps me stay on task. I don't start, browsing a website like Hackaday or Hacker News or something like that, or just watching random YouTube videos. But I usually stay on task with programming and working on this stuff. And what I'm about to do is I'm about to turn this off, and while it's uploading to YouTube, I'll also be kind of figuring out my strategy for dealing with the next thing, which is our utility class for having a factory to create whatchamacallits. My brain went dead again. Our factory to create don't even know anymore. An object pool, that's the word, and our reference counting. So I'm looking into that. All right, that's it. And in that case, as usual, well, I hope it's been somewhat educational for you. Thank you, and have a great day.